How are resources used in industrial process simulation? Imagine being able to see how every part of a factory works before making any changes. That's what process simulation does, and resources play a big role in making it accurate. Resources are all the inputs needed to run a manufacturing process. Think of labor, machines, raw materials, energy, and time. These are the building blocks that keep everything moving. In simulation, these resources are carefully modeled to mimic real-world operations. First, process mapping helps identify what resources are used at each step. It's like drawing a detailed map of the factory's workflow. You specify which machines, workers, or materials are needed for each task. This gives a clear picture of how resources flow through the process. Next, data collection is essential. You gather facts about how much resources are available, how fast they are used, and what they cost. For example, you might find that a machine runs for 8 hours a day and costs $50 per hour, or that a worker can assemble 100 units in an hour. This data sets the baseline for the simulation. Once you have the data, you develop a model that includes all these resources. The simulation software uses math and algorithms to show how resources are shared or used up during production. It can show, for example, if a machine is idle too often or if workers are overburdened. Then, you run the simulation with different scenarios. Maybe you increase machine hours, add more workers, or change raw materials. This helps identify bottlenecks or inefficiencies caused by resource constraints. The results tell you how changing resources impacts overall performance. You might see that adding an extra machine reduces cycle time or that reallocating labor improves output. These insights guide decisions on how to best use resources in real operations. After that, you implement the optimized plans and monitor their effectiveness. In Industry 4.0 environments, digital twins, virtual copies of physical systems, allow real-time simulation of resource flow. This means you can test and adjust resource use instantly without disrupting actual production. Practical examples include spotting underused equipment and reallocating it to improve efficiency, or testing how adding automation affects resource consumption and speed. Simulating supply chain resources can help predict delays and adjust schedules accordingly. It also supports lean manufacturing and Six Sigma projects by showing where waste happens and how to reduce it. In the end, resources are the core variables in process simulation. Accurately modeling and adjusting them helps manufacturers stay flexible, improve productivity, and stay competitive in the fast-changing world of Industry 4.0.